So the next format we want to look at is XML, which is short for Extensible Markup Language. And the thing about XML is that it follows what's called a tree structure, and it has tagged elements. It has a lot more detail that is attached to it than JSON does. So it's a sort of harder to look at to read because it can be kind of a little bit hard to read, but all the information is actually there. And along with each along with each element, you also get a set of attributes. So this is very much like HTML actually, because they both have the same root language. It's a little bit like Spanish and French are both Latin-based languages, and Italian, I assume, are Latin-based languages. Similarly, XML and HTML are both have the same root language behind it. And in the way this works is that you get a tree of tags or attributes. So you get a tag, another tag, another tag, another tag, another tag, and then under this is the actual text. That is the data that you want. The data is always on the leaves, and the leaves could be in multiple places. You could have a data right here, for example. But the data is always in the leaves. So to get data in an XML tree, what you have to do is you have to traverse the tree in whatever direction you want to go till you get to data. That's the basic idea with XML. So let's take an example. So here's an example, right? And you can see that it's not it all makes sense, but it's sort of hard to read because there's a lot of peripheral information around here. So in this example, what we have is a bunch of books, and for each book we know the title of the book. That's the title, for example, New York Deco, and we know the first and last name of the authors, and we know where they live. And we also have some other information like the weight of the book, not that you should judge a book by its weight, but just in case. The price of the book and the ISBN of the book. So that's the basic information that we have. And all this is sitting inside our XML tree. And our goal really is to extract this information from that tree. All right? And we know it's a tree because the tree has a root at bookstore, and we can take a look at it. So let's look at our XML example in the form of a tree. So in the tree, we find that there's the root of the tree is a bookstore. And under the bookstore, we've got two books, book 1 and book 2. And each book has a bunch of attributes. So here, I haven't listed them all here, but we can see that this book, for example, has an ISBN, a price, and a weight. And then under the book, there are two nodes or elements. One is the title here and the authors. And then is the actual data itself, the title of the book, New York Deco. And under the authors are the list of authors for that book. So we can follow the tree along here as well. There's a book which probably has a bunch of attributes not listed. It has a bunch of authors, and the authors are, each author is one subtree of the author's subtree. And author 1 has a first name, a last name, and then under each first name and last name element are the actual names of the authors. So we've got Bill and Harris. So we have an author called Bill Harris, first name Bill, last name Harris. So this becomes our tree, and this is just another way of looking at this XML structure over here. That's the root. It has two sub-elements, a book and a book. Each sub-element has an open element book and a close element / book. And for the elements of book, for the book element, we have a bunch of attributes, and the attributes are ISBN number, price, and weight, etc. So we can go down here, author, for example. Authors, for example, have an author residence, New York City, an author residence, Beijing, author residence, New York City, all that kind of stuff, right? So so as you can see that there's an open tag. The open tag contains the attributes, and the closed tag doesn't contain any attributes, which makes sense, right? So this is our tree structure. Our goal is to traverse this tree structure and extract the data. The data being, in this case, for example, the names. Let's say, what is the first and last name of the author of the book, New York Deco? Right? So what we would need to do is we would need to find this element, the entire book element. And from the entire book element, we figure out, yes, its title is New York Deco, and the first name of the author is, look at the author's subtree, and look at the author subtree, this one here. and then extract the first name and last name as the leaf nodes of that tree, and we can get the data. So that's the whole idea in XML. It's a little bit more complicated than JSON, because JSON is easier for people who know Python, programmers who know Python, because you can convert the JSON object directly into a dictionary or a list, and then we know how to deal with lists and dictionaries, and we can traverse them very easily and get data out. But here we're getting a structure that's slightly different, so we need to actually figure that out there. So as always with Python, when you want to do something, there's a library that will do it for you. There's a library for everything in Python. It's a library for whatever you want, right? For finding flights to Mexico or whatever, right? So let's say we want to start with this library. The library that we're going to use LXML, and from there we're going to import this object, eTree, the object definition, eTree. eTree is the object that will contain, or the data type that will contain the entire tree, XML tree, that we're going to get from a file or wherever it shows up from, okay, or the internet or whatever. So we've got the eTree object. So the first thing we want to do is we want to figure out the root of that tree. So and this is just a variable name. Remember, it doesn't mean root. We call it whatever we feel like. But what we're going to do is we take our data element, and data, if you recall, is nothing other than this string, right? So this is an entire Python string. So we have this Python string, and that becomes our data. We take that data element and we give it as an argument to the function XML in the eTree library, right, in the eTree module, and that produces for us the root of gives the whole entire tree actually, and returns just the root of the tree. And then we can print the tag of that. And once we have that, we can do various things to actually examine the tree itself. So let's take a look at this in our Python notebook. Go back to our notebook here, and so we have our XML object over here. So this is our data string that contains our entire XML object, right, and exactly what we had over there. And then we import eTree, which is what we want over there, right, and then we can get the root, and we look at the root itself and take a look at it, and it tells us that we haven't actually done this part here, so let's do that. And it tells us that our the type of tag that we have is of type str, right, because that's the whole thing over there. So now, because the XML structure is, you can think of it as containing the data, which is this entire structure here, and extracting the structure from this string, and that's what we do by the XML function itself. So let's go back to this here, and we can look at print our tree itself, and we find that it's essentially just printing the tree structure, okay? And we have to decode it from UTF-8 because using UTF-8 because it's a byte string. So we got that. Then, so what we want to do is the first thing you might want to do is iterate over the XML tree. So if you want to extract all the elements in the tree, we can use an iterator. An iterator in Python, which is very useful in general, is it's a generator that doesn't actually, something like the range operator we saw when we were looking at Python last week. It doesn't actually instantiate every element, but it generates them as and when we want them. So iterators are very useful for that. So what we're sort of doing is we're saying we have our tree structure, and the tree has a bunch of nodes in it. And what we want to do is we want to construct an iterator that is going to sequentially go over these nodes and return them one by one to us so that we can do something with them. So let's take a look at what this does here. So I get the root.iterator here, and in fact what I can do is, let's take a look at that in a second. I can print each element, and what it tells us is that our tree contains a bunch of elements: a bookstore, a book, a title, authors, author, first name, last name, etc. Right? So we get all these different elements in our tree, and we can take a look at what kind of object root.iter is. So if I say root.iter, it tells me it's an element depth first iterator. Right? So it's going to be a depth first iterator, which means that it's going to, in our tree, it's going to go down one complete branch and then come back up one step and do the next thing. So that's what we get here. We get bookstore, book, title, authors, author, first name, last name, and then it's going to go back all the way up to the next book and get that. Let's take a look at what the thing does here. So if you look at our tree here, the iterator is going to go from bookstore to book, book to title, title to authors, author to author, authors to author, then go back up. It's done all this, go back there, done all that, and take the next book, and then go on so forth. So that's what depth first iterator does.